Hello, thanks for stopping by. After making that video the other day, I wasn't really happy with the explanation that I took and gave you guys on the testing that I was doing and how I was doing it and what the results were. Uh, and especially with the images on that my little oscilloscope. So I took and fired up. I have a Heathkit scope. I fired that up, and I thought I'd take and run through it again and show you what the different circuits look like and why I think this probe circuit that we've more or less decided to use is the best of them. Now, for the testing, what I used is a modulated 455 kilohertz oscillator that I took and built. This is what the unit looks like, and this is the schematic for it. The section there on the left in orange, that's approximately a 400 hertz oscillator, and the output from that goes over to the right hand section, which is a 455 kilohertz oscillator. So the 400 hertz oscillator powers the 455 to take and give a modulated signal, and this is what the raw signal looks like on the oscilloscope. You can see it's a modulated 455 kilohertz. I mean, it's not perfect. It's not totally asymmetrical or whatever, but it works good for a rough alignment of a radio, or using it for signal tracing on the radio is what I took and built it for. Now we'll take and start off with Heathkit probe. And this the standard Heathkit probe. They just used a 1N34A germanium diode, a 1 nanofarad capacitor, and feeding the signal through. This is the waveform you get. You can see that it's flat topped. I mean, it does not look like a 400 hertz sine wave. I can only assume that when it goes through the internal circuitry to the 12AX7 and the T4, or to the Darlington transistor that they use in the IT5283, that it smooths it out enough, filters it more to take and give a purer tone. Now, as the board is currently made, this is what the circuit was, which is a modified version of the Restore Old radios. I just took and swapped the location of the 1 nanofarad capacitor. And this is what the output of that looks like, which you can see is basically the same as the other, only not quite as high. Now, all these waveforms are with the same scope settings. I didn't change anything to change the height of the wave or anything. They're all made with the same scope settings. Now, the original input circuit that I have in my my first one, my big one, and that were in our first prototyping boards, was this one here, that used the one nanofarad capacitor, 1N34A to ground, and then a voltage divider, and that puts out this signal, which you can see. It looks more like a 400 hertz sine wave, but you can see that there's still a lot of the 455 is still in there. It's very distorted. It's nowhere near pure. And now this is the circuit that seems to work best, the one we're probably going to take and be using, building into the probe. I'm still going to take and probably do a little bit more testing on it, you know, but maybe vary R1 there, see whether that changes anything. As far as the loading of the circuit, like I said, it loads it about the same as the T4. I don't think we're going to get much better than that. And this is the output of that, which you can see, you know, out of all the waveforms, that looks the most like a 400 cycle, you know, sine wave. It's a little bit distorted there on the bottom, probably from the, you know, clipping of the diode type thing. And this is with a 1N4148 diode. And this is the same circuit with a 5711. It's a little higher, but to me the top looks like it's starting to take and get a little clippy. I'm going to take, you know, experiment with that too, and, you know, see how they sound like. Maybe varying the resistor with the different diodes will make a difference, and see. But I hope this explains a little bit more on what I've been doing and why I think that, you know, out of all the ones that I've tried so far, uh, this one sure has, you know, the best looking and the best sounding signal. So I'd like to thank everybody for stopping by, and have a good day.